Hello. Yeah, I can hear you great. I know. It's the same location, it's just rotated. Let's see. Yeah, let's see. Same room. Hey. Yeah, I thought I'd show you the books because I'm gonna talk about how I might lend you guys some books. Yeah, so these are not all my books. These are a combination of mine and my wife's books. All the math books are mine. So all of these ones, these are all the math books. And I think there's a few more behind the monitor there. Yeah. Oh yeah, I wouldn't be surprised. I think that the two of us, we talked a lot about how we have a lot of the same books. So yeah, so we've got a few people here. I guess I wouldn't be surprised if a few of us maybe forgot that that today's the day that we're getting back together. So I'm going to try to keep it short and sweet because this portion of the class is not really intended to be very instructional. It's intended to kind of be what in the education world we call inquiry based. So you're kind of looking at your own questions and kind of making it up as you go along and kind of making your own problems and seeking what you find interesting and doing it that way. So what we're gonna do is I'm just gonna kind of describe some of the topics that you could choose for your final project. I'll talk a little bit about some of the expectations that I have for your project, and I'll give you some ideas of some topics that you can maybe start thinking about for your final project. So I'm really excited about this portion because I'm really interested to see what you guys come up with. So I thought what I'd start off with is just sort of an introduction to some topics that you may find interesting. So keep in mind that these are just suggestions for topics. If you have an idea that you already have that's like something that you're really interested in, then absolutely you can study that. But I would like to know what your idea is before you actually start doing research and writing and things like that, because I would like to just verify that it is mathematical, right? So math is a pretty broad term, and there's a lot of different areas that math comes up in, but I think that it's important that I just kind of sign off on it before you do a deep dive into a topic that you find interesting, because maybe it's not quite mathematical enough. So if you do have your own idea, that's awesome, but I would like to hear about it first. So what I thought I'd do is I'd just go over kind of some of the books that I have, and that would be a good place to start because I do have quite a wide variety of books. And then while I kind of go over those books, I'm just going to sort of talk about what topic that book covers, and also maybe just some ideas that kind of come from that book that you might want to pursue on your own. So what I thought I'd start off with is one of my favorite books here. This is Contemporary Abstract Algebra. So, and I guess this is flipped for you guys, eh? I thought that, I guess, I guess it doesn't really matter. Yeah, I mean, it's mirrored. It says Contemporary Abstract Algebra. You don't really need to read this, at least not on the computer screen. So this is a fantastic book. Now it is fairly advanced, but I'm not necessarily talking about what's inside the book, like page for page, but kind of what the idea of the book is. So this is a book on algebra, and algebra kind of seems like one of those topics that, I learned algebra in grade 7. Like I'm an expert in algebra. Well, abstract algebra is a little bit different, and what it does is it thinks about what algebra is like without the context of just being in like the real number system that we're dealing with, where you can think about algebra in a completely different way. And what you're really doing in abstract algebra is you're thinking about how arithmetic works in an abstract way. So like how can you like what is the nature of addition? What is the nature of multiplication? What does that mean? Like, what does that mean if we wanted to multiply things that weren't numbers, that didn't have value? So that's what this book is about. It's really, really great. If you wanted to study algebra, I wouldn't necessarily give you this particular book. I mean, you could borrow this book if you wanted to, but there's a lot of really good resources that are maybe a little more entry level in terms of what algebra is. In particular, I think that if you wanted to learn about algebra, I would suggest that you start out by learning about something called a group and doing a project on group theory, because groups are kind of the first sort of algebraic object that's covered in this book and pretty much any algebra book. So I would suggest starting with group theory if you're interested in that. So algebra is really neat. Like I say, it's kind of like thinking about what the nature of mathematical operations are. So like, what does addition mean? What does multiplication mean? So that's this book. So this would be a good place to start. Go ahead. Sorry, I didn't quite hear that. I think your audio is breaking up again. Sorry, can you type it in the chat? I can't hear you. Oh, who's the author? Oh, this was Gallian. Joseph Gallian. I think that this is a slightly older edition. I think this is the 7th edition of this book, and this one is, they use this at the University of Winnipeg. So if you are thinking about studying math at the U of W, you might actually want to take a look at this book. I know that it is maybe a little bit advanced, but it's a fantastic book. It's got lots of examples and a lot of fully worked solutions and things like that. Really thorough descriptions. It's a very well written book. It is a textbook. It's not like a novel or anything. I mean, most of the books I'm going to show you are textbooks. So there's this option, and there are many others. I think that kind of like the Bible of algebra, like the be all and end all algebra book, is written by Dummett and Foote. That's their names. I'll just write that name in the chat in case you wanted to write that down. So Dummett and Foote. It's Foote with an E at the end of it, if I recall correctly. Let me just double check. Dummett and Foote. Yeah, yes, that's how you spell it. Richard M. Dummett and David S. Foote. And that's a huge book. It's really, really thick, but it's pretty much got everything that you would ever want to learn about algebra. So that's kind of like the exhaustive book. But this is a fantastic introduction. It is very thorough, and in fact, this is used in 2 classes at the University of Winnipeg. So if you're interested in algebra, you might consider this one. But if you're only a little bit interested in algebra, then I can make some suggestions for maybe just some easier to digest online options. So there's that. Next one I have here is this book on linear algebra. So this is by Friedberg, Inzel, and Spence. This is not the book that I would recommend for learning linear algebra. I have another book at school. I think I have maybe 2 or 3 books at school, like in my classroom, that I would lend you. But this is the only book on linear algebra that I have. Or I guess I have a couple other books on linear algebra. I guess maybe this one is something that I would actually consider lending you. This is quite accessible. So yeah, this book is I guess all of these books. Linear algebra in general is about solving systems of linear equations that have many, many variables and many, many equations. And basically you learn how to use a matrix. And I believe that that's something that you would have done if you did grade 10 advanced. I believe that that's on the grade 10 advanced curriculum. So you may have got just a taste of it in grade 10, but linear algebra goes all out in terms of like what a matrix is, what a vector is, how can you make many vectors become a matrix. So there's a lot of really cool stuff about linear algebra. Linear algebra is a very, very useful area in math in terms of its applications to science and computer science. It's a fantastic skill to have. So like if you're planning on doing some engineering or any kind of science, having a good background in linear algebra can really help, because there are just so many applications of linear algebra. So yeah, I've got it. I guess I have a couple books on linear algebra here. These are all very good books, but I would probably only lend this one out because this one is kind of like your introduction, where these two are kind of not very introductory. They kind of assume that you have a background in linear algebra already. And I have a few other books on linear algebra as well. So there's these ones. Okay, I guess I'm going to have to put these back. Ugh. Otherwise they'll all come toppling down. There we go. Okay, what else do I have here? Okay, so this is, I'll kind of just throw in an oddball. This is a really cool book. And I guess while I'm at it, I could kind of throw these in. Yeah, Girdles Proof. This is an amazing book, Girdles Proof. It is, it's a story. So this is actually a novel, like with an author. And I really wish that this wasn't mirrored. I'm gonna see if I can multitask here and see if I can figure out how to unmirror a video in. No, I can't multitask. As soon as I start thinking about something else, then I'm not going to be able to do it. Wait, can I do it? Does anyone know quickly how to transform? Oh, flip horizontal. There it is. Yeah, okay. And then now I just have to move this. There we go. Aha. Yeah, what's up? I guess I haven't really thought about that. I get a chance to win 50K? Or you? Hey, that's not bad. What's the junior challenge again? Oh, yeah. I think you told me about that. Yeah. Let's. I'm gonna explore that as soon as this is over. Yeah, I forgot about that. You know what? I like that idea. So. Well, I don't know. I mean, I think we can all make our own decisions. But yeah, I'll talk a little bit more about kind of the expectation and the format at the end. Okay, so we'll continue on with the different topics. I'd highly recommend this book for anyone who is just interested in mathematics in general. This was one of my all-time favorite books, like all books included, like non-math, just like it's very well written. It talks about the history of one of the most important math problems ever. It completely changed the course of mathematics, and I cannot recommend this book. Or I mean, there's many other books that sort of tell the story, but the thing about this book is that it's very accessible. It's like a little more than 100 pages. I think it's like, excluding the appendix, yeah, it's 113 pages. So it's a very straightforward read. It's accessible. if you don't have a math background, it's still readable. But if you do have a math background, there's enough here for you to really bite into and sink your teeth into. It's a really, really great book. So I'd highly recommend this book. It would be a fantastic project idea as well to just retell this story. Yeah, I think this could be a fantastic topic. So Goose wants to come say hi to everyone and show you her butt. And yeah, hi Goose. Okay. And then, so the idea, so the topic here is logic. So this is a book about logic, by the way. That's why I brought this other book here on logic. And if you wanted to do logic, you could take a look at, oops, this is upside down. You could take a look at logic and mathematical logic. And there's lots to say. Goose, no, don't eat my headphones. They're hungry because we ran out of cat food this weekend, and they eat this very special cat food because one of them has allergies. So we couldn't get it over the weekend, so now I have to go buy them cat food. So they only got a little bit of food this morning as the breakfast, and then now they're starving and they're bugging me like crazy. Anyway, so this is a book. I would not recommend this book pretty much to anyone. This book is I really did not enjoy having to read this book as a university student. Just to give you an idea of just sort of like the stuff that you're dealing with. Like this is on page 30. Like it's stuff like this. Like what? Yeah, it's notation, but it's just it's a really, this was a really heavy book, and I really struggled with this. I mean, it was interesting. It was really interesting. But it's so esoteric that it's really hard to get motivation to finish this book. You can see I made it about halfway through, and yeah. So logic is absolutely a very cool topic. I'd highly recommend doing logic, especially if you're thinking of doing something with computer science. I know that a lot of you have sort of expressed some interest in computer science, which is awesome. On the topic of computer sciencey things, this is another topic that you could cover. This is graph theory. Graph theory is one of those topics that when it was first introduced, several hundred years ago, there was no clear application, and as many topics in math start off, it came out of just solving interesting problems that people thought were kind of interesting. And now graph theory is utilized in like network and computer security and things like that. So if you're into kind of like IT type of computer science where you're thinking about networks, graph theory is a fantastic topic. So even if you don't choose this, but you are interested in doing some computer science in university, I would highly recommend taking a course in graph theory. It is very fun. It's I think I probably had the most amount of fun in graph theory. It's very enjoyable. It's all like pictures and diagrams and things like this. You're talking about nodes and edges between nodes. And I think honestly in this day and age, you're probably, oh yeah, look at this. This is the how graph theory started, is with the bridges of Königsberg. And that was the introduction of graph theory right there. And yeah, so just to give you an idea, the bridges of Königsberg is a very like trivial question, and it's kind of a silly one. It was just like, can you walk around Königsberg without passing the same bridge more than once? And like, can you visit like this part of the city, this part, that part, and then this little island without passing the bridge while crossing each bridge exactly once? So like, what kind of question is that, right? Like who cares? You could just cross a bridge a second time, not a big deal. But thinking about that problem and developing like a system to like translate these bridges into basically its essence, that was the dawn of graph theory, and now look how cool graph theory is, and all the cool stuff you can do with graph theory. So it's a super fun topic. This would make a great project. The only trouble is that typesetting these little graphs can be a little bit challenging, but I'm sure that you have some kind of program like Inkscape. Inkscape is really good for making these little programs, or Photoshop, or some variant of Photoshop like GIMP. So yeah, that's another topic. So if you're interested in computer science, graph theory is fantastic. It's super fun. Let's see here. What else do I have? Oh, here's a fun one. So another kind of topic that I was thinking that you might have, and it's kind of in line with Gödel's proof, is, and you might not see the connection right away, but the idea is like a history kind of idea. So thinking about the history of mathematics. So this is Euclid's Elements. This is the world's first textbook, was Euclid's Elements. There's 13 books. I think this is, what is it, book, I don't think, yeah, this is just books 1 and 2. The first book, I forget if it's the first book or if it's the first 2 books, gives it's all done with a ruler and compass. So you'll see a lot of circles and stuff in here. And this book right here is kind of more like the historian version of the textbook. I have another version of this book that's just the book. So the idea of this one is that I think that it covers some of the Greek translation, because it was originally written in Greek. So this one is like a really deep dive into the history and how people translated it throughout the years. So yeah, like it has like some Greek in it, which is cool. But this probably wouldn't be the right copy for you if you wanted to just do like a quick project on Euclid's Elements. Anyways, the first 2 books, or just the first book, I forget which, does a ruler and compass, like compass as in this kind of thing. It gives a ruler and compass proof of the Pythagorean theorem. So what's important to understand about Euclid's Elements is that these were not Euclid's. Oh, hi Goosey. She just wanted to play with this. So Euclid was not actually the mathematician behind all of these topics, or all of these results rather. Just like this book here, Saxon, right? This is an awesome book made by this guy named Saxon. Saxon did not invent all of this math, right? I mean, this book was written in this particular edition, I think, was made in 2018 or something, right? So obviously not the discoverer of all these topics, just like Euclid was not the discoverer of this. But Euclid was the first person to compile all of these results from other people around Greece, because this was written in ancient Greece. A little bit before Plato, or after Plato, must have been after Plato. So maybe around 300 BC, something like that. My dates might be a little bit off. I guess it would probably, I wonder if it's copyrighted for like a BC copyright. Anyway, yeah, so the idea is that this is the very first compilation of results that was told in a way that there was like a narrative and there was pedagogy. So it was like, these are the first things that you need to know, and then it was like next step, and then finally building to deeper results. So really cool book. These are also really fun to do, to actually reconstruct these geometric constructions. So basically what they tell you to do is make a circle centered here with your compass, connect this line with your ruler, and it's actually not a ruler, it's actually a straight edge. So a straight edge is the same thing as a ruler, except there's no marking, so there's no millimeters or inches or anything. It's just a straight line. So you learn how to make all these really interesting things with by making circles and drawing straight lines. And it's pretty cool. Like, I think one of them is to make a hexagon. And that's really fun to do, to make a hexagon with just a ruler and a compass. And it's not just any old hexagon, it's a regular hexagon, which means that all of the sides are the same length and all of the angles are the same angles. Yeah. Oh, look at that. Oh, wow. We have a PDF of Galleon score. I will definitely save this. Yeah, this is a great book. So just in the Discord chat, someone posted something that you may find interesting. Let's see what else I have here. And back to computer science, cryptography. This is, yeah. So again, this isn't necessarily the book that I would recommend for cryptography, but kind of the purpose of what I'm doing here is I'm just looking through my little collection of books, and it's just going to remind me of topics that you can cover. So cryptography is, I certainly have a bias because I studied cryptography quite a bit, and it was part of my master's thesis was to talk about cryptography. So I certainly have a bias, but I still think that cryptography is the most important area of computer science. I think that if it weren't for cryptography, war would not be the same, e-commerce would not be the same, just nothing would be the same without cryptography. And what's really cool about cryptography is that you can really get a good sense of cryptography right away. You don't need very much mathematics to understand some of the crypto systems that we still use today. For example, the RSA crypto system is probably one of the most widely used crypto systems, and it's quite straightforward to understand. The one thing you just need to understand is modular arithmetic. So kind of like the clock arithmetic, where 11 o'clock plus 3 hours isn't 14 o'clock, it's 2 o'clock p.m., right? Or I guess if you're thinking about military time, but even then, right, like 23 o'clock plus 5 is not 28 o'clock, it's 4 o'clock, right? So that's the main idea behind cryptography, is this notion of modular arithmetic and all the interesting results that come out of that, which actually goes hand in hand with algebra. And you can't do cryptography without algebra. So these two topics go hand in hand. So cryptography is a really, really fun one. Also important if you are thinking about studying computer science. It would be weird to do a study in computer science without thinking about cryptography, because cryptography is just so important. So there's that. Another fun one too, which might be a little more advanced, is combinatorics. Combinatorics is really, really fun. This was the topic that I ended up sort of pursuing in grad school. So I really, really enjoyed this stuff in my undergrad. It was a lot of fun to think about combinations and permutations and things like that, and all the interesting things that come out of it. So again, this is not the book that I would recommend. It's a great book. Some people would say it's the Bible of combinatorial enumeration, but still not very accessible unless you already know a fair bit about combinatorics. But definitely one topic that you could think about. And let's see here. Going back to oh, by the way, so here's Gödel's proof. So basically, I'll just tell you a little bit about what Gödel's proof is. There's these mathematicians, you might have heard of them. There was Bertrand Russell, I guess you can't see that, Bertrand Russell and Alfred Whitehead. And they wrote this monstrosity of a triple volume. And this you talk about like esoteric mathematics. Like look, I mean, I'm just gonna pull out a random page, and don't just try to tell me that this is just notation. You have to wrap your head around the notation. Like look at this stuff. It's just it's like, so the first volume is almost 700 pages. The second volume is over 700 pages, and the third volume is 474 pages. So, and it's not like it really like lightens up at all. Like still, like this is just a random page in the third volume. I mean, it's really, so you can imagine how deep these results must be. And basically what they ended up proving, like what they tried to do here is they tried to demonstrate that mathematics was they thought it was like mechanical, that you could have a physical computer just punch out and solve every single math problem and discover every single mathematical idea that there possibly could be. And in a lot of ways, that's kind of an upsetting idea, that humans aren't really needed in this pursuit of mathematics. And so they spent the better part of a decade writing this stuff and making discoveries and basically building a system, like a theoretical system, to just pump out mathematics and just to make just new discoveries. And that basically eventually the idea is that one day a computer could be built that would just discover every single thing about mathematics that you could ever want. And it's not quite like that, but that's kind of like the Cole's Notes version of what this is. Obviously there's some nuances in that. And then Kurt Gödel came along, I think sometime in the 30s or sometime around there, maybe even a little bit earlier than that, and basically disproved it. They said, I read your treatise, I hate to break it to you, but you're wrong. And that humans are needed in mathematics. And even so, basically what he did was he took their system, their theoretical computer, and used that to create a problem that it wouldn't be able to solve. And that's what this is. So I just thought I'd show you, because I have these books. They're quite hard to find, especially these old editions. And I scored them in a very lucky way. I'll tell you about that some other time if you want. So that's those books. I guess one topic that I haven't really got into very much is analysis. So that is kind of like just what we've been doing with calculus. So there's definitely a lot to keep studying with calculus. A couple of things that you could continue to study, like basically just look at what comes next in calculus. And there's several ideas that you could, I mean, calculus is a massive topic, right? There are almost endless topics within the realm of calculus. So one idea that you could do is you could look at multivariable calculus. And I think all my calculus books are at school now. I think I brought them all after our last class. So yeah, I don't have any calculus books on me, but I'd be happy to share some resources with you if you want to continue studying calculus. So just to throw some ideas around, you could look at perhaps the theoretical definition of a limit, which is, I think, really interesting. So we always use limits in kind of what we call in the math world like a hand-wavy way, that a limit is like, oh, it's getting really close, so it's getting arbitrarily close, but like what does close mean in a mathematical sense? So you could look at what a limit is, and I think that's a really interesting topic, and it's not something that you learn typically until your second year of studying calculus. So it is really interesting. That could be an excellent project. You could also look at multivariable calculus. So that's where you're looking at no longer like a two-dimensional plane. You're looking in 3 dimensions. And we did a little bit of that, like with the rotating of the different shapes and things like that. So we're not totally strangers to 3 dimensions. But I mean, really, what multivariable calculus does is it thinks like, okay, imagine you've got like a wavy plane, right? Like, you think of slope as in a 2-dimensional way, like a single line. But if you have like a 3-dimensional sort of like wavy ground, like you can imagine like the Windows XP background with like those green wavy hills. Like, what would the slope be in 3 dimensions? And you realize it's actually a plane. And it's like if you had a plane and you kind of like were pressing it down onto a single point, at what point would that plane be tangent, as in it's only touching at a single point to that point? So that's an interesting topic as well. That one might take a lot of effort, but it is something that's really, really useful in engineering, especially. So if you have an aptitude for engineering, that might be a topic that you might want to study. And then of course there's the deeper analysis. So this is kind of the more theoretical aspect of calculus. And I wouldn't necessarily recommend this particular book, but I'm just pulling books off my bookshelf to remind me of these different topics. So analysis is kind of like the backbone behind calculus. So analysis looks at how you can describe this notion of continuity. So we have this idea of continuous functions, but analysis really explores what it means to be continuous. So that would be one idea. Another idea as well is something called topology. Topology is kind of a mix between graph theory and analysis. So if you kind of just smash these two into one, then topology comes out. And topology is an incredible topic. There are so many cool subtopics of topology. One especially that is interesting is algebraic topology, and I think that those of you who partook in math club know about algebraic topology, because that's where knot theory comes in, and braids. So that's all part of algebraic topology. So topology is a very big topic, and there's many other subtopics. And in fact, graph theory, part of the way graph theory came to be is also through topology. So yeah, there's that, and I'm just kind of throwing some more ideas out there. You could continue to study differential equations. We kind of just touched the surface of differential equations, but there's a lot more to study with DE. Let's see what else. I thought I had a couple more. Oh yeah, I mean, you could also do something interesting like study the Fibonacci numbers. So there's a lot to be said about the Fibonacci numbers and its connection to the golden ratio and stuff like that. So that would be kind of a more accessible project. So if you're maybe feeling a little overwhelmed with the scope of the project, studying the Fibonacci numbers is kind of bite-sized, but there's enough interesting math that I think it would make for a great project. There's one more here that I saw that I thought would be interesting. What's this one here? Yeah, here's another book on graph theory, Counting Labeled Trees. Got a bunch of interesting old math books. Look at this, 95 cents. That really dates it. This book is interesting. It's funny because I remember reading it several years ago, and then I kind of skipped the introduction, and I finished reading the book, and I felt very accomplished for reading the whole book. I felt like this was really interesting. And then there's this. It says here. I don't know if you can read this. The present booklet contains a set of problems which were the themes of several meetings of the School Children's Mathematical Club at Leningrad State University. So it's for like little kids, but I still think it's pretty neat stuff. I mean, it's interesting mathematics. So you could do something on Fibonacci numbers, absolutely. Yeah, I think those are. Oh yeah, I remember now. I'm looking at the other end of my bookshelf. Set theory. This set theory is along with logic. Between logic and set theory, those two ideas form the foundation of mathematics. So set theory, that's where our numbers come from, and our axioms come from. So this is a very, very interesting topic, very important to just the general field of mathematics. Sorry, Goose is just trying to remind me that she's very hungry. And now she's trying to eat my books. Hey, bye, Goose. You're not allowed to do that. Go away. Okay. She just put a hole in my shirt too. Great. Okay. Yeah. So set theory is really interesting. It looks at axioms, and which are kind of very simple statements that are impossible to prove or disprove. Just like a very, very general statement. And you look at how those very simple statements can be combined with each other to be built up and built up and built up until you have a system of thinking about how numbers work. And it's interesting because you have to make sure that these simple axioms don't contradict each other. Right? You can't assume two things that contradict each other. But at the same time, you need to make sure that these axioms, you've made enough axioms that you can actually start to prove things interesting. And so this book introduces what we call the Zermelo-Franco axioms, and it kind of talks about their role in mathematics, and how you can use just simple things like the notion of the fact that there's an empty set, and the fact that you can build sets from other sets. And then just those two simple assumptions, you can build the natural numbers. And then from that, you can build the integers. And then from that, you can build the rational numbers. Building the real numbers is very challenging. You need analysis to build the real numbers. But you can kind of think of it like, okay, so the way math works is that you have logic to understand what's true and false. You have set theory to build sets, like just groups of objects, which leads you to the natural numbers, which leads you to the integers, which leads you to the rational numbers. Then finally, you need analysis to build the real numbers, because those are very challenging to build. Although you can use algebra to build certain types of irrational numbers. And then finally, you can use complex analysis and also algebra. So these two things together make the complex numbers. So that's kind of the story of mathematics. So all in one, that's kind of how this stuff is all related, is just by building numbers and thinking about how numbers work. So I think that should be a lot of ideas for you. And don't get me wrong, like math is, according to this guy, math is endless, right? So you can make up your own topic if you want. So I'm hoping that this is a good sort of source of information for you to think about the different topics that you want to study. I know that Mr. McIntosh told me that in previous years when he covered this topic or this class, he would give lots of ideas to students, and then students would still come up with their own idea. And it doesn't have to be like a traditional math topic either. Mr. McIntosh told me in the past that he had students do things like on artificial intelligence and things like this. So if you kind of have an idea of something that you're already interested in, and it's something that you've been sort of meaning to study for a while, you've been interested in it, but maybe you haven't found the time. Like maybe you're interested in how Bitcoin works, right? Like what's the mathematics behind Bitcoin? It's super interesting. Yeah, and the mathematics is not inaccessible. Like the whole point of Bitcoin is that anyone can understand it and implement it themselves. So yeah, if you wanted to study something like that, by all means, you can do that. But I'm hoping that this kind of like tour of my bookshelf might sort of give you some new ideas, or if you didn't have any ideas at all, maybe it'll give you some other ideas. And also, if you would like a suggestion for a topic, please just send me a message, and I'd be happy to help you find a topic. So I could either just tell you, it's like, yeah, no, you're doing graph theory. I can do that for you. But if you want to find your own topic, then now would be a good time to start doing it. Are there any other questions about topics, or do you want to start talking about like expectations and due dates and things like that? How are we doing? We good? We good? Okay, I'm just gonna double check YouTube. Okay, no one's talking on YouTube, so but there is one person. Hi, one person. Okay. Sorry, Goose just needs attention right now, or maybe she doesn't. So yeah, let's talk about some of the expectations. So there's okay. I'll talk about first. I'll talk about format. Okay. Then I'll talk a little bit about scope, and then maybe we can talk third about like working in groups and that kind of thing, and how that would work. Because I actually do like that idea, and I think that actually would make it a little more fun. Okay, Goose, no one wants to see your butthole. That's gross. Goose, okay, bye. Okay, okay. So first of all, format. I'm pretty open to format. I think that the most straightforward format that I can think of is a paper. But maybe you think that's boring, and if you do, that's totally fine. But you know, you can actually have a lot of fun with a paper. I've had a lot of fun writing different papers myself. If you wanted to, I could give you some resources to learn about LaTeX and how to typeset your mathematics in kind of a professional way, and the way that would be expected of you kind of in higher level mathematics. So that could be one option, is just to do a paper. If you wanted to do a presentation, as of next week on June 1st, teachers are actually all going to be back at school. Distance learning or remote learning will continue, so it's not like classes are just going back to normal. It's not that, but teachers are going to be going back to school. So if you wanted to do a presentation, what we could do is, presumably I would be able to live stream at school. Currently I cannot, because my computer is incapable of encoding video. It's a very low-end laptop. It's kind of a piece of junk. It doesn't have USB 3, which is required for my little doohickey here. I guess you can't see it, but my Elgato capture device requires USB 3. So currently I cannot live stream, but I have made a request for a new computer, and that should be coming sometime soon. So what I'm trying to say is that as of next week, if you wanted to do a presentation, then you could live stream it. You could come to school, you could come to the classroom, and just use my streaming software. This capture device just takes an HDMI input, so if you wanted to do like a PowerPoint or some equivalent of that, some kind of presentation with slides, you could fire that up on your own laptop, as long as your laptop has a way of exporting, or not exporting, but what am I trying to say? If it has a video out port, then we could plug that into the capture device, set you up with a webcam, and you could do a live presentation to your classmates. So that could be one option. If you wanted to pre-record a presentation as well, or not even thinking of it as a presentation, but if you wanted to just make a video and post it on YouTube or Vimeo or any other kind of video hosting platform, you could do that. That's another option. If you wanted to, like, I don't know, build a website or something like this, you could absolutely do that. anything else that you can think of too. I mean, I'm mostly concerned, or not concerned, but my focus is on the math. So like, however you decide to present the mathematics is up to you. I will be assessing you on the mathematics itself. So do you have any questions about that, or are we good on format? Do we have any questions about format? Okay, that's a good question. I guess if it was to be so it's hard to say with the different formats. That's why it's challenging to do this. But I mean, I'm doing projects in my other classes as well, like with the grade 9s and 10s and 11s, and we're doing projects. It's kind of like a final assignment kind of thing. So for those classes, what I've told them is that I gave them the equivalent amount of work if you were to do an essay, because that's easy to measure, right? So I would say between 4 to 5 pages, double spaced. So if you were, and that's if you were doing a paper. So as a paper, somewhere between 4 and 5 pages worth of material. So that's easy to measure if you're doing a paper. I think that would translate probably to an 8 or 9 minute video, something like that. But I mean, I'm less concerned with like the measurement of length than I am with the content. So what I'm really looking for is like, did you make it past the first page of a book? Did you make it past like the introduction of the Wikipedia entry, right? Like, I expect you to do some research. I expect you to dig your teeth into something. If you're able to do that and demonstrate that you really looked into this and you actually did some genuine research, like, I don't expect you to like make a discovery or anything like that. I mean, let's be real here. Like, this is like a 3-week project. Then yeah, I don't have any huge expectations for that, but I do want to make sure that you've actually done some research and sunk your teeth into it and had fun with it, and yeah, I want you to demonstrate that you're actually interested in this topic. So I think in that sense, it is really important to choose a topic that you're interested in. So, I mean, I'm really happy to give you a topic. Like, if you're feeling stuck and you don't know what you want to do, I'd be more than happy just to tell you what to do and be like, okay, yeah, here's a topic, here's a few resources, here's a book that you can borrow if you want. But at the same time, I think it would be better for you if you kind of looked at some of the topics that I talked about today, or think back on some of the topics that you are interested in, and choose a topic based on your own interest, because then you'll have that motivation that you might not otherwise have. So yeah, does that answer your question? Okay, and I will be posting a rubric very shortly on how I will be grading this. All in all, I mean, I don't want you to worry too much about the grades. I mean, I kind of am seeing this class in particular as kind of like a celebration, like kind of like a fun sort of cherry on top. You'd really have to mess up to not get a good grade. You'd basically have to just submit almost nothing. Like, I'm not saying that I'm just going to be giving out, 95s to everyone just because you showed up, but I'm not here to stress you out in the last 2 weeks of high school, right? You guys have already demonstrated a tremendous amount of mathematical rigor. Like, I'm not looking for something that is going to stress you out and to really be a downer in the last 2 weeks of school. So yeah, I'll be making a rubric, and I think that the rubric should just be there just to sort of guide you in terms of sort of framing your, like, the structure of your research. I hope that you don't think of it as like, okay, I have to do this, and this, otherwise I'm going to get a bad grade. It's not going to be like that. Like, you guys have already done calculus, right? You've done the super hard, stressful math that you do in high school. Right now, we're just having fun, thinking about cool topics. So I implore you not to worry too much about your grade. I think that as long as you are able to demonstrate that you're interested in this topic, I also want to make sure that you're not giving false information. I do want there to be some accuracy in your project, and so you can't just make stuff up. But yeah, I truly believe that if you choose a topic that you're interested in, and I really do believe that there is room to find several topics that you're interested in. I mean, I'm hoping that at least one of the topics that I showed you find interesting, but there are just so many other topics that are interesting as well. I mean, like, just thinking about the way computers work. I know probably over half of you are gamers, and there's a lot of mathematics in, what goes on behind the scenes in a video card, thinking about like what is like real-time ray tracing. Like, what's the mathematics behind that, right? I mean, there's a lot of really cool stuff that you can study. So I think that as long as you find something that you find interesting, you'll be totally fine. You'll get a great grade. So I really don't want you to worry too much about your grade, because I think that as long as you find something fun and you enjoy doing it, then you'll be totally fine. As for due dates, June 12th. June 12th is the big day. So I have to have my marks in on the 17th. So that gives me less than a week to grade your topics, as well as all of the other projects that I have for my other classes. So June 12th is absolutely the latest day that I can accept the project. So if you want to do a presentation, like a live presentation, it would have to be that week. So June 12th is a Friday. So that gives us a total of 3 weeks, including this week. So we've got this week, the week after that, and then the week after that, that Friday, that's when the project is due. So if you wanted to do a live presentation, we can certainly do that, but we can't have everyone coming in on June 12th, right? We can only have one person come in at a time. Just obviously because of COVID and all of that stuff, and we have to respect the regulations that are in place. But yeah, if we wanted to do a live presentation, then yeah, we would have to do it throughout that last week. So you would have to finish a little bit earlier if you wanted to do a live presentation. And if you wanted to do like a group live presentation, then we might have to start thinking, like, if you want to be in a group, which I'll talk about in just a minute. If you did want to be in a group, then I think we would have to think about doing something like a Zoom or Google Meets kind of thing, where we kind of have multiple screens at once, and that we all kind of stay at home, because I don't think I'm allowed to invite more than one student at a time. So if you did want to do a group and you did want to do a live presentation, there may be some complications in that. So just something to keep in mind. Yeah, okay, so there's that. And then, groups. So if you did want to be in a group, I'd like to know as soon as possible. So I actually have a little form for you guys to fill out. Just 1 second. I'm just going to quickly adjust the form so that I can check to see if you want to be in a group. 1 second. It's advanced math sign up form. Oh, look. Oh, someone already submitted it. That's awesome. I'm just gonna add one more question on here to see if anyone wants to be in a group. So, do you want to be in a group with a P, and I'll do yes or no, and then I will add, if you do, who is in your group. So I will add a section. Just let me do this in real time, so that way I can just tell you to fill it out right now. So who's in your group? And then I'll just add a text field, short answer, okay, and I want you to do, okay, and this is go to section based on answer. What is Goose doing? She's licking the, oh my god, she was licking the screen. That's why the exposure changed, because she wanted to expose to the white background. Oh my gosh. Goose, go away. Yeah, they're really hungry. Okay, so do you want to be, and then if you answer this one, go to section based on answer, after, okay, how do I do that again? Oh yeah, yes, continue to next section, no, submit form. Okay, perfect. And then this one is required. Okay, so that should work now. And okay, I've got one response. So if you've already responded, you know who you are. If you wouldn't mind just messaging me privately if you are planning on being in a group. And I guess if you were planning on being in a group, one of your group members could just submit the form telling me that you're in that group anyways. But here's the thing, 3 people to a group. I don't think we can do more than 3 people. So 1, 2, or 3 people per project, okay? And keep in mind, if you do have a 3-person group, like I will have a higher expectation for content. It's not like it's gonna be like additive, right? It's not like I expect a 3-person group to have 3 times the content, but I do expect for the project to be a little more polished, right? Because you have 3 people working on it. Maybe go a little bit further in depth. Keep in mind that working in groups for projects can have a tendency to kind of result in one person doing the majority of the work, and then the other people kind of chiming in, oh yeah, I'll do this, and then they forgot to do it. So just keep that in mind. But yeah, I do like the idea of working in a group so long as it actually does work. But I have gone over time a little bit. So for this sort of class, I don't think it makes sense for us to like meet every day. So what I thought we could do is every second day we can meet. So today's day 2, I believe, and yeah. So today's day 2. I'm pretty sure today's day 2. 99% sure it's day 2. So let's meet every even day of the school day cycle, and it doesn't have to be like a super long meeting like this. Like this was an hour long, but I just want to sort of maybe just check in and see how the projects are going. You guys can ask some questions, but before you go, I guess in terms of like an exit slip, I guess we're not really going to do exit slips anymore. I would like you to fill out this form. So this form is on Google Classroom. I may as well just put it in the Discord chat just to save you a couple of clicks. Copy this, and where's Discord? Here you are. Okay, so I just put it in the Discord chat so you can fill out that form. I believe you need to be logged into your school division account. So if you're having trouble accessing it, try maybe opening like a private window or like incognito mode or whatever, and that way like your personal Gmail account will kind of just not be logged in, and you should be able to log in without any issues. So and if you can't access the form, just let me know, and I'll just take down your information anyways. So yeah, if you have any questions about the project, kind of if you need some guidance, don't hesitate to reach out. I'd love to help you out. I think that this has the potential of being very fun, and I hope that you're looking forward to it. If you're feeling stressed out by workload, let me know, okay? And we'll figure something out. But I mean, this is your last few weeks of high school. You guys have like what, 3-4 weeks of high school left? Like, we should be celebrating. Like this is a fun thing, and I hope that you can see what I mean when I say that it's fun, and that it's not just the teacher being like, yeah, this is going to be so great. Okay, look at this. She's eating Kleenex now. Yeah, she's a little bit hungry. Okay, Goose. Okay, my God, you're crazy. So yeah, I hope that you're able to have fun with this one. And if, like I said, if you're feeling stressed out about it, and it's just like if you just feel like you can't do it, you know, you're kind of reaching for straws, then let me know. We'll figure something out. You know, you guys have you know, basically been through to hell and back, right, with these AP exams done online, and I know that it didn't work out very well for everyone. So so yeah, if you're feeling like you're maybe a little bit stressed out, let me know and we can talk. But maybe by finding a group or doing something in a group, that will work out. So so yeah. Anyway, stay in touch. I'll talk to you guys on Wednesday then. I'll kind of just do a little quick check-in. It doesn't have to be like an hour long like this. Just 10 minutes, just see how you guys are doing. And yeah, please don't forget to fill out that form so I can kind of get an idea of what you want to do, if you want to be in a group and that kind of thing. And yeah, I'll talk to you guys on Wednesday. So, bye-bye.